monkey, then I said yes, Artemia is the sea monkey. Small pouch, a very small pouch. That time itself we were charging about $1.25 for a small pouch. So this is the topic I have chosen, and that's my email ID. Anybody wants to get in touch, 939@yahoo.com, that's my mobile number. So I'll be covering the topic why Artemia, and there are so many other feeds available. Then what is the main source of Artemia? From where do you get all the eggs or the cysts? Then current situation in India, and then what are the future prospects? That's the female Artemia, and of course I'll be showing it many. Now according to the World Fisheries and Aquaculture Production, yeah, for about 2,000 manual I managed to get. The capture fisheries inland and marine, there's a slight dip between 2010 and 12, whereas aquaculture 59 million tons to 66 million tons. Anyway, that compensated. The total is about 158. Fish and fishery products are the most traded commodity in the world, and the shrimp accounts for about 15%. And 600 species, different species of fish and crustaceans and other organisms, including algae and seaweeds, are raised in about 190 countries. There are 100 million people directly or indirectly involved in aquaculture. Asia accounts for 89% of world aquaculture production. FAO wants the per capita fish consumption from 18. Currently it is about 18 kg per year. They wanted to raise it to 30 kg. So they are also attaching a lot of importance to aquaculture. Now, this of course you are very familiar, Blue Revolution. A couple of days ago there was a big news item in the Goa newspaper, Times of India. India is unleashing Blue Revolution, and this is the data, I took it from there. 2010 to 2015, the earnings almost tripled, 12,000 to 33,000 crores, and then we have major plans to take it to about 100,000 crores in the next 5 years. So government probably has already laid a plan for about 3,000 crores. That is by 2020. How they want to achieve the 100 crores? Through inland fisheries, marine fisheries, deep sea fishing, and aquaculture. Then 50 different types of fish and shellfish are exported to about 75 different countries. United States is the major buyer from India. India exporting around 27% of product to US, followed by Southeast Asia around 26%, and rest of the European Union around 20%. This is about 327 finfish are cultured. Crustacean, shrimp, lobsters and crabs around 62 different species. Mollusks about 102. Amphibians, maybe frog and all that's about 6 species. Sea urchin, sea squirts, jellyfish. So these are the major organisms cultured in different parts of the world. So Artemia as a live feed, the brine shrimp Artemia plays an important role as a live feed. Any successful aquaculture project needs Artemia at some stage or other. So that's the thing. So fish, they relish Artemia. Shrimps, of course, at the field stages you feed them different and this is how they come out. When they hatch out, they come out like that. That's the male with the clasper to hold the female during mating. Those are the eggs, dried eggs. They come in cans, so you open and then put them in conical containers. We had to give aeration from the bottom so that the eggs are all kept in suspension all the time, and then see water salinity. Then light must be a source, and temperature should be maintained at 30 degrees centigrade. They hatch out within 24 hours, and those are the ones. So these are the cans in which they come. So I'll be talking about how they produce and all that. Why do
Can you just
herbivores?
explain that cyst part a little?
Yeah, this is the cyst. It's about 200 micron in size, and when they are dehydrated, they look like a damaged table tennis ball. The moment you put them in ordinary seawater, they all absorb moisture and then they become completely spherical. And when the right types of conditions are given, like salinity, temperature, and light, then the development is triggered. The cyst inside has an embryo developed up to blastoder stage, and it remains dormant for any number of years, hundreds and hundreds of years. You can keep them viable, and then at any time you can just take them out, put them in seawater, they hatch out within 24 hours.
So the shrimp eats the larva that comes out
Yeah,
of it,
that's it.
but
That's
it
where-
doesn't eat that cyst at all.
No, because sometimes what happens, when you feed them, they also ingest the empty cyst. So that will go and block the alimentary tract. So we always give they are photopositive, you give a light source, they get attracted, so you can siphon out from there and then straight away feed to your predators.
Is it harmful in case they take
Pardon?
larger fish? Larger fish may try to take the cyst on the whole. Is it
Which one?
slightly larger fin fish?
Yeah.
They may eat away the whole cyst also, isn't it?
Yeah, there's a possibility. If you mix them and give, there's a possibility they will inject along with the young ones that those empty cysts also. We normally avoid. Otherwise they go and unnecessarily block, and then sometimes the outer corion, we call it as a corion, they contain some harmful bacteria. So they are also injected along with that. So we have to do some disinfection, treat them, and then you hatch them. So next is why that the question I put. Why herbivores and carnivores prefer Artemia, even though Artemia is not present in their natural habitat? This was actually a question put forth to the audience in the first international Artemia conference held in Corpus Christi in 79 in Texas. So they got a lot of answers. First of all, it's an off-the-shelf, on-demand product. You can just keep Artemia in your pocket, millions of Artemia in your pocket, and then that's the reason. It's called off-the-shelf, on-demand product. For live feed like rotifer and daphnia, you have to maintain a separate culture all the time. Whereas here you can just, when your post-larvae or your fry needs the Artemia, so you can time it, hatch them the previous evening, because it takes about 24 hours, exactly at the right moment you can give them. Known amount of naupliae. Suppose you take 1 gram of Artemia, about 270 to 280,000, that is 280,000 young ones will come. So you can calculate how much naupliae you need for your hatchery, and then accordingly you don't have to waste. Accordingly that much amount you can put for hatching and then collect them and then give. Timing also important. How much time it takes. There are certain strains, they take about 36 hours. There are strains which will take about 24 hours, 20 hours like that. So timing is very important, because you have to feed them when they come out. Because they are rich in energy, they have the yolk present in them. If you don't allow to be fed immediately, then they consume their own yolk. So what you are giving is less energy than naupliae. So you have to, as soon as it comes out, you have to collect and then give them. You should not allow them to grow to next stage, that is the metanaupliar stage. Naupliar stage, metanaupliar stage, then juveniles and then adults.
Then they survive in freshwater also?
Yeah, the Artemia and naupliae thrive in marine and freshwater hatcheries. You can hatch them in 35 parts per thousand, ordinary seawater. Once they come out, you can also put in the hatchery, freshwater hatchery. For 6 hours they can thrive. Up to 6 hours, absolutely no problem. Artemia has got a very efficient osmoregulatory system. You can hatch them in ordinary seawater, throw them in 120 parts per thousand, they will remain. Nothing happens. You can also put them in ordinary seawater or 5% or even freshwater. People say, my professor was telling once, I can even thrive in sulfuric acid, mild sulfuric acid. Such a sturdy organism. and rich in nutrient contents. So the culture is, after that, the culture is, what are the expectations? Simple production procedure. Just to open the can, put them in conical containers, leave it for, for incubation, and then within 24 hours you get the young ones. Easy disinfection. The eggs can be disinfected with bleach, sodium hypochlorite or calcium hypochlorite, just to give a wash for about 5 minutes. Nothing is going to happen to the outer corion immediately. So you can get rid of all the bacteria which are attached to the outer corion. So that is easy. Then salinity temperature tolerance. They can wide temperature tolerances. They are up to 40-45 degree they can tolerate. At the same time, they can be even in 0 degree. Nothing happens. The different sizes and forms are available. You want to give it a bigger Artemia, you can give bigger Artemia. In the nursery, you can give the juveniles. Then used as a carrier, that is very important. Suppose you want to give anything like EPA or any vaccine, any pigments, any antibiotic, any DHA, any yeast, anything can be given to Artemia, not the ones which are immediately hatched out, but 48 hours, because the alimentary tract is not formed when they are born. So it takes about 48 hours. Then they are non-selective filter feeder. Anything 50 micron in size, they will ingest. So you can give, at any given time, the alimentary tract is full. People say you can even grind glass powder and give them, they will ingest. That's why they are called non-selective filter feeder. So whatever you give, that can be given to the fish, and then fish can, it goes inside, and then the whole thing bursts, and whatever you want to give, it's already there in their system. So that's a very convenient. Probably the ornamental fish people who want to improve the coloration, they can give some color pigments, and then through Artemia to the fish. That's one advantage.
The sizes that you are talking about, what is the largest size that it will reach to?
The maximum size of Artemia is about 1 centimeter. 1 centimeter, 12 mm, that's the maximum size. And they are all upside down swimmers. They are always pointed towards the sunlight or any light. So they will be back swimmers, 11 pairs of appendages. So that's how the current is created and all the food particles are brought into their system. That's why they are called non-selective filter feeders. Predator also has some preference. It should be a clean material, no alien, clean, and then no alien material, no disease, acceptable, bright color. When you see them in the nature, when they hatch out, it's nice pink and orange color. So that's really attractive. Then continuous slow movement. They move very slow. So the predators have enough time to just, otherwise they have to hunt them out. Then they have to spend more energy. So that's another. Then palatable flavor, ingestible, about 480 micron in size, so easy to. So these are the preference of the predators. Then nutritional, they have, Artemia nauplea have digestible enzymes are there, digestive enzymes are there, amylase and trypsin, and the nutritional requirements also compared to all other organisms. Next slide. See, protein is in a very good percentage, 52, 56, adults sometimes even have about 60% protein. Lipid around 18 to 11, and carbohydrate and ash. Then they also have a lot of amino acids, all in good percentage, milligram per gram. Aspartic acid 113, 135, like that. In addition, Artemia nauplea have carotenoid pigments in them. So that's another advantage when you feed to the fish and the predator gets that color. PUFA, another important EPA. 25 omega-3 is a good percentage, which is very essential for marine larvae. Then you have 18 omega-3, which is essential for freshwater. That is called alpha-linoleic acid. Then some strains also has DHA, docosahexaenic acid. That's also in good amount. So these are all their quality. Now, where all the Artemia comes from? Its main source is the Utah in the United States. That's the Great Salt Lake. This is a photograph from the space, aerial view. This is how the Artemia comes in the wild in the Great Salt Lake. Miles and miles of Artemia eggs. You can see the brown patch floating and coming. They have spotter planes. You can see the wing of the plane. So they go and find out where exactly coming, and then they will inform their shore fleet. So the fleet will immediately rush to the spot and contain them. This is the fleet which will come immediately, put the boom, the rubber booms, just to how we contain the oil slick and all that. They cover up everything, don't allow them to move, then suck immediately from that spot. And they have the sacks, burlap sacks they call it, into that, and then all the water will go. Artemia eggs are collected and then taken to the shore for further processing. So this is the Utah State Division of the Wildlife. The entire Great Salt Lake is under their control. Length is 120 kilometers long. Breadth is about 56. The licensed harvesters are about 79. They have the certificate of registration, COR. Everybody should carry, each and every boat should carry the COR. Annual license fee is around $12,000. In addition to that, they have to pay 8 cents per kilo. Because when they collect, they also collect other kachara material. You know, they have beetles, cricket, and grasshoppers. There's so many things, but that doesn't matter. Even unviable Artemia eggs. So they have to pay, and then the time of operation is October to January. So they use the GPS, night vision techniques, spotter planes, then booms are used to contain and gather. So there are about 79 companies in Royanon. So these are the data, harvest data from 1986 to 2009 I got. And they monitor. I'm told that they have a record for about 100 years on the water quality of the Great Salt Lake, whether physical, chemical or biological, and they keep a very tight monitoring on their harvest. If anything goes wrong at any time, they immediately stop the harvest. It happened a few years, sometimes in the mid of 90s. They stopped the harvest for about 2-3 years. They found the male population was much more than the female. Suddenly, you know, they also monitored the sex ratio. Suddenly it was topsy-turvy. Female population was low and then the male population was high. So they just left it for a couple of years till the original situation comes back. Like that, any nutrient or any physical parameter, anything happening, they will immediately stop. They go up to 12,000, they went up to 12,000 metric tons. These are all the differences. 79 companies, each company has its own brand, and this is only a few samples, otherwise there are much more. And of course the expense, they are spending $12,000 plus that, and then other overheads, processing, boat maintenance. So that's how it becomes very, very, very expensive. So in 1974, only about 23 metric tons was consumed. Not many people were into aquaculture. Then it doubled in 1946. Then when everybody started aquaculture, then it suddenly shot up to 900, then went up to 8,000. Then the price also from $1 a kilo up to now $100 a kilogram. In fact, I was exporting to the United States way back in 1971, 72, before MPDA was formed, under open general, I'm sure. About 2 tons I exported to a guy in San Francisco. He paid me $1.25 per kilogram. So 2 years, and that story will come a little later. So we cannot afford, especially the hatchery people, because it increases the cost of production of your fry, your post-larvae, your seeds. Because if this is going to consume, the feed is going to consume that much of this thing, so you cannot afford. So what is the other alternative? You have to look for your own resources or source at your backyard. So then everybody started looking for Artemia. Then they found it's in almost all the continents, not only in the United States, North America. Then you have in Iran, you have in Africa. Then of course in India we have, plus of course Philippines, Vietnam, and all those places they introduced later. There are different species. Earlier we used to call them Artemia salina. So that was the original name. Everybody was calling Artemia. Any Artemia, you say Artemia. Then they found out that Artemia salina is not only one. There are several Artemia. Some of them, they were reproductively isolated. There are difference in chromosomal numbers, diploid, triploid, pentaploid, decaploid, like that. So then they started working on the genetics and other things. Then they came out with 6, 7 definite species. Artemia franciscana from probably San Francisco Bay. Then you have Artemia persimilis. Of course, still Salina is there. Then Urmiana, Lake Urmiana is another huge lake in Iran, Lake Urmia. So that's another one. And then Kazakhstan, they also have. Then India, China, and some places in Africa, they have the parthenogenetic strain. Parthenogenetic strain, no males in that, only females and females and females. So that's what we had it in India when we located Artemia for the first time. Then these are the, about 600 spots are there right now. Or if you don't have a natural Artemia, then you have to go for artificial culture. The first culture was tried in Brazil. There was an abandoned salt pan, about 5,000 acres. So in that they went and introduced 250 grams of eggs. Quietly they came out. And the next year when they went, they found 2,000 tons of Artemia. Then the following year, about 5,000 tons of Artemia. So like that. Then we tried it in India, way back in '79. Then Philippines and Vietnam. Just to demonstrate it that it's possible in India to culture it.
Where did you try in India?
Yeah, that's coming. I'll come on. So how normally we do is we pump in the seawater into the salt pans, inoculate, we hatch known amount of Artemia, inoculate them, allow them to grow. Those are all the thick Artemia population, very thick. That is during certain time of the year. Artemia has got 2 different types of reproduction. One is the viviparous mode of reproduction. That is when the conditions are favorable, good salinity, good temperature, good oxygen, good food. They produce the young ones. Each female Artemia will release about 300 young ones once in 5 days. So those young ones which are released into the water, they take another a week to 10 days to become adult, and then they start the process. So what you introduce as at 10 individuals per liter will become about 6,000 to 10,000 individuals in a matter of 2 to 3 months. So we allow them to have the viviparous mode of reproduction so that there's enough population built up. Then automatically when the conditions become unfavorable, that is approach of the summer, you have temperature going up. Once the temperature goes up, the salinity will go up. Once the salinity goes up, the oxygen level will come down. Food will be a limiting factor. Then they switch over to egg production, oviparous reproduction. That's the time they release. They know, the mother will know that the young ones will not survive the hostile environment because everything is going up. So they release the eggs coated with the shell. They all get washed ashore. The eggs, fortunately, the eggs all float on the surface. They don't sink, unlike the Streptocephalus, the freshwater counterpart. They also produce eggs, but they sink to the bottom. Very difficult to catch them. Once we collect them, then further processing is done at the lab, and then that's the can we produced in Tuticorin, Marion. It's almost equivalent to any foreign container with eggs, good eggs.
Any drying is required after
Yes,
the
yes,
harvesting?
yes. We should not dry in the open sun because there is some amount of liquid inside the embryo, so that will get heated up very fast. So in the shade or in the hot chambers, so for around 30-32 degrees, that should be fine. These are the occurrence of Artemia. First, it was found in Bombay near Vadalan. Dr. C.V. Kulkarni is the first man to 1953. Then Indrachan Bay in Sambar Lake. It's again a saline lake, inland lake. There he found, of course, later on he migrated to Pakistan. Then Tuticorin I found in 1970. I'll just go off the track. When I joined for my PhD in Madurai, Professor Krishnaswamy asked me, I was a marine biologist at that time joining the freshwater lab. So he said, since you are a marine biologist and coming from Tuticorin, you should try to find out the Artemia in your area. Because we have been looking for Artemia processacea in Anamla University, then Professor Krishnaswamy, even Dr. Panikar he mentioned. They've all been looking for Artemia in the southern part. We didn't get. So on the Sankranti day in 1970, we were driving along, we found lots of flamingo birds in a water body. It was a lagoon. So it's a beautiful sight to watch them, chase them, they all take off like an aircraft to land after some time. So when I was returning, I found some red worms wriggling in the water. I thought it should be Artemia. So I came back to Madurai and then asked Professor that I have seen. No, you wouldn't have seen Artemia because we have been looking for it for a long time. But when I explained, he was excited. Immediately go and bring it. I said, I'll just come, I'll go after 2 days. When I went, I not only found large quantities of live Artemia, plus the eggs. Tons and tons of eggs were just lying there. Nobody knew about it. The fisheries department or Central Marine Fisheries, nobody knew about it. So I was collecting. Then he said, when I brought it, he was very excited. He went to the Vice Chancellor and said, one of the best findings for the year is locating Artemia for the first time in the southern part of India. Then he said, you are going to be a millionaire. I said, how? There's a great demand for it in the United States. I said, how to? No, go through the literature, material methods, you will find from where they have got the material. So in fact, I wrote to 6 of them. Only one fellow sent a $5 bill. He said, whatever sample you have, send it. I'll pay you 0.75 per pound dollars. Then when I sent the material, he was so impressed with the quality. He said, I'll double it, $1.25. So whatever you have in hand, send it. So 2 years continuously I was exporting from the Madras port to San Francisco. His name was Morris Rakovich. He was holding a company, big Artemia processing company in California. So the birds still come. They are the carriers of Artemia. The dry eggs get attached to the web. They come to feed. They say the continuous feeding on Artemia only made them the pink color. It's called the Phonicopterus roseus. That is the greater flamingo. Even today they come. Millions of them come to. So wherever. Then I wrote to Salim Ali, the great ornithologist. What about the route of how they come into India? Then he wrote a letter. Those days, inland letter. He said they come to Rann of Kutch for breeding. Great Rann of Kutch for breeding. So, but he goes to a place called Karagoda, he was the only person who was allowed to go there by helicopter to study the behavior. Then, of course, with much difficulty, I went through border security posts. We had to get, because it is under the almost closer to the Pakistan border, the Great Rann of Kutch. All along the Saurashtra and Kutch coast we found all the salt pans right up to Kutch. Then Great Rann of Kutch, I was looking for Artemia. I thought somewhere it should be there. Then one site I went, I found this much height, thickness, about 1 kilometer long, about a 2 meter breadth. Artemia, its eggs are lying there. It's a huge, but since it is a border, we didn't want to go and meddle. Because every time you go, you have to get the permission from the chief guy, the battalion head, then sector commander, area commander. Everybody will be watching what you are doing and all. In fact, once I was collecting, somebody is watching through the binocular. The next day he asked me, you were collecting something in the cans and all that, what is that? I never told that I had come for Artemia. I said, I'll just come to see the feeding behavior of the flamingos. So we came out of that. Then 10 years later I went, it was still there. Nobody has tried to harvest, it's still there. We can go and harvest probably.
It is Kutch.
Great Rann of Kutch. It's again about, just like Great Salt Lake, huge. Only thing, the depth probably about 1 meter or 2 meters. It comes in during the monsoon, the water comes and then they get washed ashore, the eggs, they remain, they go back. It's the first border with Pakistan. So I have gone through the entire, about 35 posts are there. I went through all the places and everywhere Artemia is there. These are all the parthenogenetic strain. Diameter is larger, 283 GSL. San Francisco is really small. Then volume index also is large inside. Length of the nuclei also slightly bigger, 495 micron. That's how they probably told that it's unfit for feeding. It's not so, because when you feed the your post larvae, they are not going to gulp it. They will tear them apart. And then so this question of size doesn't arise at all. Of course, the only thing the parthenogenetic strain lays about 80 to 100, because they are larger in size. Their clutch size is only about 82. Whereas bisexual strain 250 to 300, yes, they will be releasing.
You said in India it's all parthenogenetic.
It was parthenogenetic.
Now
Now you don't see parthenogenetic at all, because so many hatcheries were in Tuticorin and all along the Andhra coast and Bombay, Gujarat and all that. Everybody was using mostly the bisexual strain, and then it got spread out everywhere. So fortunately, the original stock I went and deposited at the Artemia Reference Center, which is in Ghent, Belgium. So anybody going there, they can take. There are about 600 all from all the spots. They have it's a huge almara, glass almara. It's all sealed nicely. You can just go and take whatever sample you want. You do the studies, biochemical or any damn thing, put them back. So the original stock is still being maintained. There is a reference center, Artemia Reference Center. They have done enormous work in all fields. That's in a place called Ghent. Dr. Patrick Sargelos is the father of Artemia. He has gone round the world and popularized, and he was instrumental in artificial culture.
So the species that you get in India is that Selena only or some other?
But now it's all the Great Salt Lakes, bisexual strain. So the Great Salt Lake strain, now it's been introduced and then they have come to stay permanently in India.
Okay.
Super parthenogenetic is not here. If it is there, it is called Artemia parthenogenetica. In bracket, you put Tuticorin. If it is found in Hyderabad, you put Artemia parthenogenetica in bracket Hyderabad. That's the name. So the first artificial culture was done at Mundra for a private salt company, Bharat Salt and Chemical Industries. I was not very much familiar at that time. I was only confined to the laboratory experiment, how to hatch them, what is the best suitable salinity, what is the best temperature, like that. So this company guys came and said, we want Artemia culture to be done in our salt pans. Then I got a little panicky and I have never done. So Patrick is a very close friend of mine, so I sent an SOS, can you come down and then help me? He took the flight, came down to Mundra, and then he taught me how to go about, how to hatch them, how to introduce. We selected the best pond and all that. And then within a month we started harvesting the eggs. 12 hatcheries were supplied. This is through NIO. We are charged them those days hardly about 1.5 lakhs. That is the fees we charge. But we helped them. So that was a successful, and then he has mentioned it in the giant prawn. Next thing was done at Singat Salt Works belonging to Toppers. You must have heard about Topper water base, Vikram Topper and all that. So the Toppers wanted to have Artemia done in their saltons, very close to Jamnagar. So we produced around, there we introduced the GSL strain. We produced around 3,000 kilos. And that time there was a restriction on import of Artemia eggs, imported Artemia eggs. So everybody was buying. They are the people who make sunlight bond paper. So they wanted to have the same name, sunshine. So we supplied to 42 different hatcheries the eggs. Very good hatching percentage. The highest hoofer level ever recorded for any Artemia was that. Then we found out It's because of Artemia feeding on Dunaliella and spirulina. So it was a monoculture like in the ponds. So that boosted the presence of very high EPA and DHA. OSPAC and TOSPAC run by Empira hatcheries. You must have heard about OSPAC and TOSPAC. Odisha Shrimp Seed Production and Research Center. And then the Andhra Pradesh shrimp, that is I think was in Vizag, I think. Yeah. So they were regular buyers, about 100 kilos every month. One Dr. Venkatesan Empira was in charge. So he wrote a very nice letter that the quality is good and thankful to the company and to us for providing things. So that's how it comes. Very nice golden brown color. And then you just harvest them. You contain them and then you harvest them. Then the third one was done at Sahai Mada Salt Pans near Tuticorin. That's the largest salt pan in the southern part of India. 3,000 acres. Salt, they produce something like about 1.6 lakh tons of Artemia. They also, the table variety salt, iodized salt, they are packing for Tatas, they are packing for Hindustan Lever. Then they have their own sprinkle which is exclusively distributed in Kerala. So they have people, plus they also produce several other chemicals. Bromine is another very expensive chemical. So there we just introduce, see when you do it in the salt pans, you should never meddle with their routine salt production because that's their breadwinner. So you can't go and then block here, block there, I want to do this, no. We just select the pond. What happens is in the salt pans, pumping the seawater, there are huge reservoirs where the seawater is stored first, then allowed to evaporate, and 35 becomes 45, 50 like that. Then they start slowly opening to different condenser or evaporation ponds. So in a salt pan 3,000 acres, about 500 acres will be the reservoirs, and 1,500 acres will be the condenser pans because they have to circulate for a while. Then the crystallizes where exactly they make the salt is only about 200 or 300 acres. So we produce about 20,000 kilos of frozen biomass, and then under the brand name we were selling to all the hatcheries along the Andhra coast and then Madras coast, plus ornamental fish people in Maharashtra as well as in Bangalore. They were also regularly buying. This is how we build on the biomass freshly collected. Every morning we go and collect the adult Artemia. Bring it to the lab and then quality control, get rid of all the unwanted things, and there will be plastics and there will be cigarette butts because the laborers they do all sorts of things. And then we immediately pouch them, seal them, and then store them in containers, or deep freezers, -4, then they are shipped anywhere. First people to start using is BMR. There's a big hatchery called the BMR hatchery. So those are the people who bought from us, and then regularly they were the first people to give a license for Vanamai hatchery. So they were buying from us on a regular basis, 200, 300, 500 every 10th day. Then other Vanamai people came to know about it, why these people are buying, then they also started buying. Then we asked the hatchery people at the BMR, why you are buying such a lot? He said, when they import the Vanamai brooder, they feed them with clam or other types of meats. But it takes time, 3 weeks to a month before they really mature and breed. Whereas when they gave Artemia, they were maturing in within about 10 days. So that's one of the reasons they were buying on a regular basis. Then the another product is freeze-dried. The same frozen Artemia can be lyophilized or freeze-dried, and then because Artemia contains about 90% water, so we can get rid of all the water and then have quality remains the same, easy to transport, and the flavor, everything is there. But I think it's a little expensive. You load 1 kilo, after 24 hours only 100 grams of it comes out. But it's not become, it hasn't become very popular in India, whereas in other countries they use. So that's another product which we've been doing. And then decapsulated Artemia X. That's another new product which we introduced. That is to remove the outer coating by chemical treatment and have only the embryo. So once you remove the outer coating, which is made up of lipoprotein, then you can treat it as a normal egg. It can be directly fed also without hatching. The energy is very, very high. The moment you allow them to hatch, they lose certain amount of energy for breaking open the two layers, outer layer and inner layer, and then come out. And then this also, it gets disinfected. And at times, suppose you want to hatch them also, you can hatch them. Instead of 24 hours, you can hatch them in 16 hours. And it's a beautiful color. Directly you can throw them into the hatcheries and they can, even to the fish fry. So that is a decapsulated.
Why do you use the word decapsulated?
Because the capsule the outer coating is called capsule. The Korean thickness,
yeah,
the brown, that we get rid of it because it takes time to open it. To come out. So it's easy, and then some of the eggs may not hatch all the time.
So it is no longer a cyst, isn't it? It's actually an egg.
It's an egg. Only thing, the outer coating is not there. The cover is not there. We have removed the cover. Only
but the cyst is still there.
Still there.
Oh.
So once you have removed, it's just like an ordinary egg. Then you can play about with that. You can store them in high density brine. You can do anything you want. You can also feed them directly. That one advantage is there, and growth is very fast. We have done some experiment with nauplii, freshly hatched nauplii, adult, and then feeding decapsulated eggs to milkfish fry. And milkfish fry in 2-3 weeks time, it almost double in size. So that's very, very rich. Then of course these are the one is a regular can. It's all 1 kilo cans. Sorry, 500 gram cans. That's a decap can. This is the ordinary can. So which are the ideal sites for doing? So normally we select salt pans, major salt pans, because they have continuous seawater pumping, because they need seawater all the time. Even if power is not there, they have to. So well laid out evaporation and then condenser ponds with varied salinity. Any salinity you want, you have, right from 35 parts per thousand up to 220 parts per thousand. But we select 100 parts per thousand because in 100 parts per thousand there are no predators. Otherwise, there are tilapia breeding in 100 parts per thousand. And so if any predators is there, because Artemia doesn't have any defense mechanism to run away from the predator. So we choose 100 parts per thousand, hatch them in ordinary seawater, 35 parts per thousand, and then straight away introduce them in 100 parts per thousand. And then one thing, prior to introduction, we have to fertilize them with the DAP and urea. So that also we cleared with the salt people. Whether adding DAP and urea in the system, will it affect their quality of the salt? All the scientists from top people from Delhi, they came on, they worked out and said, nothing is going to happen. You can introduce. So that triggers the algal bloom, and Artemia can feed on that. So periodical. Then bonds with choice salinity inoculation, availability of analytical lab. Most of the bigger salt pans, they will have labs to do their routine analysis. So we can make use of that. Then continuous power supply generator is there, most of them. Then good labor force, the cheap labor force. So you can always have some people to go around and collect your eggs or biomass or whatever you want. Then presence of Artemia improves both quality and quantity. How quality? Because most of the salt produced in India are supplied to chemical industries, and they don't want much calcium in the salt. Calcium and magnesium, they have only sodium chloride 99 point. So calcium and magnesium, Artemia is being a non-selective filter feeder. It filters off all the calcium and magnesium, and they drop down to the bottom of the ponds it's encapsulated. There is a small thin tube. So on which the halobacteria grow. Halobacteria gives a green, pink color to the pond. And it's a product which brings extra. How quantity? Because when Artemia is in high saline water, they have a body pigment known as hemoglobin. The color is there. So they become red in color, otherwise they have to artificially color them. So any red color in large quantity, they improves solar absorption. So that way the salt, quantity of the salt also improves. Otherwise earlier they used to have some dye, artificial dye. Then it's a byproduct, brings extra income to them without spending much. So these are the salt producing units in our country. Total around 11,799. Total area available is about 6 lakh acres. Units with less than 10 acres, about 87% are small salt producers, which probably may not be suitable for Artemia culture. Then medium is 10 to 100 acres, okay. But more than 100 acres, only 5.8%. It's all with Tatas, Birlas, Tappers, Chowgles, big companies they have in Gujarat. And they all know about Artemia. May not be directly, but we can convince them to take up Artemia culture in their salt pans. So this is Gujarat coastline. Tudukran, of course, I told you that place is a very Sahai Mother salt and largest salt pan. Vedaranyam is another area where salt. Kolam. And Andhra you have small salt pans, Chinnakajam, Krishnapatnam, Kakinada. Maharashtra it was there, but now due to land reclamation and lots of pollution, slowly the natural Artemia is completely gone from there. The same thing happened to Rajasthan lake. Suddenly a couple of years they had a very heavy rains and the whole thing became a freshwater lake and it's gone. Other applications of Artemia. You should not think that Artemia is used only for, of course, apart from feeding in hatcheries, and of course a lot of ornamental fish people also use. Quite a good amount goes there. Model organism, ecological and physiological studies, freezing tolerance, osmoregulation, temperature tolerance. So a lot of studies are now being carried out. Biological indicator of environmental contamination. Test organism been recognized as a test organism for bioassay studies. LD50 and all that they do. Anti-fouling paints, asbestos, heavy metal, cadmium, and oil. So how Artemia is affected. Then biomaterial for biology education. Children can watch. So multi-purpose biomaterial. Then its use in this is a very interesting, in space research. Apollo 16, 17, Russian cosmonauts, Photon, Salyut, all carry biological material, and Artemia is fortunate to go into the space every time a spacecraft is sent to study the effect of proton, neutron, synchrotron, plus the effect of weightlessness. They used to keep a sample in the ground station in the Earth, and then one inside the spacecraft, and then another set sandwiched between cellulose and kept outside the spacecraft. Then they bring it back after 1 month after the voyage, and then compare the hatching. Then they found that the ones which were exposed outside for cosmic rays, their percentage was very, very low. So that means it does get affected. Of course, there is another very interesting thing is they say Artemia is as old as dinosaur time onwards. It's been there. In Great Salt Lake, some of the geologists, they were taking core samples from the Great Salt Lake, and then they found at a particular layer Artemia eggs, and they did carbon dating to find out the age. So that time it was 10,000 years old. They tried it for hatching, they hatched. And then later on in Lake Urmia in Iran, they found that Artemia is 30,000 or 40,000 years old. But I don't know whether they tried it for hatching, but it shows that they are there. But possible they put it for hatching, it might hatch. And then freezing also. You can freeze the immediately hatched out Artemia for 24 hours. You can bring them back to life. Only for 24 hours. You hatch them large quantities. Suppose by any chance you cannot use it, immediately put them in the freezer -4, and then exactly after 24 hours you take them out. They all come back to life. So that's about it. Artemia, any more question? We will have more discussion on that. Thanks for listening. Thank you.
Thank you, sir. Very nice lecture. You have given the decapsulated Artemia,
Yes.
and a number of things you have told that they are carriers of